Hey, everyone. Welcome to I/O. I'm so excited to be here. I hope you are, too. My name is Kathryn Hurley. I'm a developer programs engineer at Google. Specifically, I work on fusion tables. And I'm here today along with James McGill, an engineer on the Maps API team, and Simon Rogers from the UK Guardian Data blog. And today we're going to be talking to you about how to use fusion tables to manage and visualize your geospatial data. So this is the agenda for the talk. I'm going to give you an introduction to fusion tables. Then I'll run through a quick demo of how to use fusion tables. Then I'll talk to you about how you can build an application using the Fusion Tables API. Then James is going to talk about Google Maps API and how you can use Google Maps API to display your fusion table data on a Google Map. And finally, Simon Rogers is going to show you some real-world examples of how the Guardian is using fusion tables to display their data on Google Maps. And we're really excited to see how journalists are using fusion tables. All right, so intro to fusion tables. When people ask me, what is Google Fusion Tables? I like to say that it's a database in the cloud that you can use to store, host, collaborate on, and visualize your data. Here's a nice example of a visualization that you can create using fusion tables. This is a map, and this map was actually created by Simon Rogers. It's showing deprivation in England. You can see he did some nice styling of the map, the polygons on the map. You can also see that the info windows were customized, and this is all built using fusion tables. All right, here's another example of a visualization you can create using fusion tables. This is a bar chart created using the Google Visualization API. Fusion tables acts as a data source in the Visualization API. I'm not going to go into too much detail here about how to use the Visualization API, but I encourage you to go to the session using Google Chart Tools to create interactive dashboards. It's occurring right after this one in room 1, and you can learn more about the Visualization API there. All right, so now I just wanted to actually jump into a quick demo of how to use fusion tables. I can show you a lot of screenshots of what the product looks like, but I think it's more interesting if I actually show you a real-life demo of the product. And there's also some really cool things that you can do in the Fusion Tables web application that I just wanted to show you how to do. And so, for example, you can merge two tables together in the Fusion Tables web application. Merging is basically a left-outer join if you're familiar with databases. You can also manage the permissions and visibility of the tables that you own in Fusion Tables using the web application. And you can also create a map and customize that map with custom info windows and map styles. So I'm just going to get out of full screen mode right now and go to Fusion Tables. And it's probably a little bit small, so I'm going to increase the font size here. All right, so I go to google.com/fusiontables. I've signed in with my Gmail account, and I'll see a list of the tables that I own. I'm going to work with these two tables down here at the bottom, ecoregion boundaries and ecoregion attributes. So let's look at the ecoregion boundary table. So this table, it contains the boundaries of various ecoregions around the world. The ecoregions are basically areas that have the same climate and plants and animal species within them. And so we got this data from the Nature Conservancy. They were very nice and shared this data with us for this demo. Nature Conservancy is concerned with preserving Earth's natural resources, so they have a lot of data about the ecoregions around the world. And this table was created from a KML file that they had containing all the ecoregion boundaries throughout the world. And this is just a subset of that data. It's the ecoregions in Australia. So let's take a look and see what this table looks like on a map. So Fusion Tables maps all the polygons that were in that KML file and places it on a Google map. Let me click on one of these features so you can see what's displayed in the info window. You can see that the data from my table is displayed in the info window. OK, let me go over to the other table that I have, the ecoregion attributes. Now, this data was also donated to us from the Nature Conservancy. And the cool thing about the Nature Conservancy is that they work with a lot of different organizations. So for example, they work with the World Wildlife Foundation. And all these organizations have specific data about the ecoregions around the world. So for example, Nature Conservancy has information about the % forest area in the ecoregions, and the World Wildlife Foundation has information about maybe the number of lizards and snakes in each of those ecoregions. So Fusion Tables allows these organizations to work together to collaborate on this data. So Nature Conservancy can upload their own table with their own data. The WWF can upload their tables and have their own data up in Fusion Tables, and then they can merge these tables together to create one fused table or merge table. So I'm going to show you how to merge two tables together right now. I'm going to merge the attribute table with the boundary table. So I just copied the URL from the attribute table. I'll go back to the boundary table and select merge. I'll paste in the URL from the other table, click get. Now at this point, I want to select the two columns that have the same values in it. So this is similar to keys in databases. Both columns have to have the same value. And the two columns in my tables are the object ID column, so I'll select both of those. And I'll call this new merge table that I'm creating, ecoregions merged. When I'm done here, I click merge tables. And Fusion Tables will work, and it creates this new merge table. And you can see that the data from both tables are in this merge table. So I'll scroll over so you can see more of the columns here. And the nice thing about this merge table is that if any of the data in the base tables that were used to create this merge table is updated, then those updates are immediately reflected in the merge table. So let's say that the WWF finds a new lizard species. They can go ahead and update that data in their table, and it will be reflected in this merge table. Now let's see what this looks like on a map. I'll select Visualize Map, and occasionally you might see a loading message. It takes a little bit of time for the data to load. I'll just refresh the page, and let's view it on a map again. And there we can see our nice boundaries on the map. And I'll click on one of these polygons so you can see the information that's being displayed in the info window, and you can see it's displaying all the information from my table in this info window. But maybe I don't want to show all this information. Maybe I just want to show maybe the name of the ecoregion and the forest area. So I'm going to update the contents of the info window to just show the information that I want. In order to do that, I can click Configure Info Window, and I can select and deselect which columns I want displayed in the info window. Or I can also go to Custom and edit the HTML. So I can really customize the contents of the info window even more. So I'm going to delete that label, maybe give this a nice color of blue, and add the closing tag here, and save. And let's see what happened to our info window. There you can see now the name of the ecoregion is bold and blue, and it shows just the % forest area in the info window. All right, so all red map, maybe not that useful. Let's actually change the styles of these features according to the information that's showing in my info window, basically the % forest area. So in order to do that, I can configure the styles for the table, and you can see there's several options for changing the style of the features on my map. If you have points, you can change the marker icon, or you can change the fill color of the polygons, etc. Since my data is polygons, I'm going to change the fill color. And again, you can see there are several options for changing the fill color of the polygons. I'm going to go ahead and select a gradient. I'm going to show a gradient on the % forest area. That's the data I'm showing in my info window. And I can customize the colors of the gradient. I'll make it a nice teal color. And I will say, I'll set the min and max for the range of the data in the % forest area column. I'll click Save. And you can see our map is immediately updated with the new styles. And I'll click on one of these regions, and you can see that the info window content is the same. All right, this is really awesome. And at this point, I'll show you how to share the table with others, because after you put all this hard work into your map, you probably want to share it with other people. So these permissions are similar to Google Docs permissions. You can invite specific people to view or edit the table. Or you can set the visibility of the entire table to public, unlisted, or private. I will set this as unlisted, so people that have the link can view it. And at this point, I could be done. I could click Get an Embeddable Link. I grab this HTML, copy it, paste it in my own HTML page, and I'll have this map directly in my website. So it's how I styled it in Fusion Tables, how I set the info window contents, that'll be available in my website. So you can do a lot of cool things in the UI. Right, go back. So I showed you how to merge two tables. I showed you how to manage the permissions and visibility of the table. Showed you how to create a map and customize that map. Now, how might you build an application using Fusion Tables? Here are a couple application ideas that I came up with. Some of these are actually being developed right now. One developer is mapping out newspapers around the world. It's a really cool application. He's styling the markers according to the language of the newspaper. He's updated the contents of the info windows to provide links to the online content for these newspapers in various translations, so you can read it in English or Spanish. And he's allowing his users to search for newspapers around their area. Another cool application I've heard of Fusion Tables is popular game manufacturer was interested in finding out which servers their users were connecting to. And using Fusion Tables, they were easily able to map this out, and they were surprised to find that a lot of their users in North America were connecting to servers in Europe, and they really wanted those users to connect to the servers in North America. And they were just easily able to figure that out using Fusion Tables, because they uploaded the data, and they could immediately map it out on a map. So let's just go through a workflow of what one of these applications might look like. So let's go through the mapping newspapers around the world application. So let's say you wanted to create this application, and you wanted users to be able to use your application and insert information about their own local newspapers into your application. So you could create a web form and/or Android or mobile application. And this application would insert data directly into Fusion Tables. And at this point, it's really easy to create a visualization of the information that's being submitted to your table. You just simply visualize it on a map. And here's an example of a map that you could create with this data. The colors, you could color the markers according to the language or some other attribute of the newspaper. I'll click on one of these. You can see that it has a name of newspaper, and these are all just fake newspapers I made up. And you can provide a link directly to the newspaper. All right, so now let's go through the details of the API, so you know how to use the API to build an application like this. The API is a REST API, so basically that means you can make HTTP requests to Fusion Tables. With these requests, you send SQL-like queries in order to create table, insert, select, update data, etc. And here's just a few examples of the queries that you can send. You can see we're creating our new newspapers table with columns for the name of the newspaper, the location of the newspaper, and a link to the newspaper. Then we're inserting data, selecting, etc. And OAuth is used for authorization. And here's just some sample code. This is written in Python, but you can write your code in any language that you want as long as it can make HTTP requests. So you can see I'm creating a query. It's creating a new table in the newspapers table, and it's sending the request. It's sending the query along with the request, and depending on the query that I'm sending, you'll get different data back. So if I send the create table query, then I'll get the table ID back if the create was successful. OK, so now I just wanted to jump over to a demo of the API. So let me just go over to terminal real quick. And this looks a little bit small. Oh, shoot. And something happened to my terminal. Sorry, let me just find where it is real quick. Sorry about this. Should have prepared this a little bit better. Oops. OK, so I have a Python file. And let me just initiate Python here. And if it's a little bit small, let me increase the font so you can see this better and increase the window. OK, so I have a Python file, and it contains a Fusion Tables class. And in this class, I can make requests to Fusion Tables, and I'll send the various queries to Fusion Tables. So I have a show table query, creates table query, et cetera. And so I'm just going to go ahead and import that Fusion Tables class. And I'll create a new instance of that. And I'll run the show queries or show tables query. And you can see the tables that I own. You might recognize some of these tables from earlier. It has the ecoregion tables. And let me go ahead and create a new table. So I'm running the create table query. I'm creating a new newspapers table and sending and initializing the 3 columns: the name, location, and link. OK, so let's just run a describe on this. And you can see the results of the describe. It's describing the table, showing the columns, and the data types for each of these columns. OK, so and this is sort of mimicking the steps that you would do if you wanted to write your newspapers application using Fusion Tables. So let's insert some data into this table, because right now it's just an empty table. And so this step is going to mimic how your users would be able to submit information to Fusion Tables. So you'd run insert statements when somebody submitted a form on your web application or in your Android app. And so we're inserting information about various newspapers around the Bay Area, San Jose Mercury News, Mountain View Voice, et cetera. So let's run a select query on this table. Now you can see that the data is in my table. We have information about San Jose Mercury News, et cetera. And it might be hard to see. Maybe I'll increase this one more time. But the link at the bottom is actually incorrect. The San Francisco Chronicle URL is not SGate, it's SFGate. And this is pretty common if you're writing an application that does crowdsourcing. Maybe your users are submitting erroneous data, or maybe changes to the data are occurring. Maybe the San Francisco Chronicle has changed the URL to their website. So you want to be able to update that data. And so we have an update statement, and we send the update statement. We set the new link to the new value and specify the row ID that we want to update. And you can see that now our data is being updated. And let's run a select one more time so you can see the results. Now the URL for the SFGate has been updated. Also, an interesting addition to this might be adding a spatial query. So Fusion Tables supports spatial queries. This will allow you to allow your users to find newspapers that are near them. So you can find the n nearest features, or you can find all the features that fall within a circle or a bounding box. So you can find the closest newspapers to your user. All right, so that's an API demo just showing you how you might use Fusion Tables to build a newspaper application. All right, so now I just wanted to announce a couple new features. We're very excited about these new features. We are now releasing to trusted testers map feature styling and info window customization, all available in the API. So I showed you how to do these steps in the UI earlier. I showed you how to style the features on the map of the ecoregions and also update the info windows. Now you can do this in the API. So this is really exciting. And just wanted to mention real quick how to become a trusted tester. You just send an email to this mailing list. This email will show up later in the presentation, so don't worry if you don't copy it down right now. We will show it again. And how do these new features work? This is a REST API similar to the SQL API that I showed you earlier. So you can make HTTP requests to insert, delete, update the styles and info window templates. The JSON objects represent the styles and the info window templates for your tables. This is an example of a JSON object representing the style of table 1, 2, 3, 4, 5. It's setting all the markers to the small blue icon. And so why is this awesome? This is really great if you're creating lots of tables. So I was recently working with the census data, and there's a ton of census data. I think I created around 200 different tables. And if I wanted to go into the UI and update the style for all these tables, it would take a very, very long time. So what I could do instead now is use the API to create the table and then immediately apply a style or a custom info window to this table while it's just in the code. So it saves a lot of time in these cases. It's also, these new features are also really cool because you can find out how public tables are being styled. So if you really liked how The Guardian was styled their deprivation map, you can use this API to find out the style of that table and potentially reuse it for your own tables. Also, a cool new feature of these new APIs, or new features of the API, is that it's part of the Google APIs console. And with the API console, you get a lot of nice things. For example, you see your quota, and you can also get analytics about your API usage. So if you're getting close to your quota, then you can adjust your code. Also, these new features are supported in the Google Client Libraries, and that makes requests to the APIs much easier, and it makes it a lot much easier as well. And again, I just want to reiterate that trusted testers are needed. Here's the email list, and we'll show this later in the presentation as well. So, OK, now at this point, I showed you how to do the back end of Fusion Tables. James is going to take it away and show you how to use the Maps API to show your Fusion Table data on a map. And he's flown all the way from Sydney, by the way, to talk to you guys. He's excited to be here.
Good afternoon, everybody. Thank you very much for coming to our presentation today. As Kathryn mentioned, I have flown in all the way from Sydney, but it's been absolutely worth it. I'm having just a great day. And I'm excited to be talking to you today because what I'm really interested in as an API programmer is making it easy for developers to show large amounts of geographic information on a map in their own websites in a way that's easy for them and useful to the people visiting their websites. And I'm really excited about Fusion Tables because Fusion Tables makes this very simple. So as I mentioned before, I'll be talking about the Google Maps JavaScript API. Now, this is a JavaScript API used by developers all over the internet. It makes it simple to add an interactive Slippy map, like you might have seen on maps.google.com, to any third-party site with just a few lines of JavaScript. But what developers may struggle with a little bit more is getting their data onto that map. Now, I'm kind of a crime buff, and I happen to have some data that shows the locations of crimes all over Chicago. And I have this map of Chicago. Using Fusion Tables, I can combine these two things with only 5 lines of code. All I need is the name of a column in a Fusion Tables that represents my geographic data. Now, this column should contain features like latitude and longitude points, or polygons, or polylines. I also need the ID of the table. If you're not sure how to get the ID, that's contained within the URL. So you can just copy that out of the URL, highlight it in blue in these slides, and paste it in the layer. And with those 5 lines of code, I get a map that looks like this, right? Very simple. And I can convey a large amount of information to the people who view my site. Now, of course, I can also filter that information. So for example, I may only want to display crimes that have occurred where the victim was over 50 years old. I use those same 5 lines of before, but I dynamically, when I click this button, add an additional property to filter the map. And the map updates instantly, and now we're only showing the subset of the information that the person viewing our site is interested in. Of course, you can set this programmatically as well. So you can let the people visiting your site decide exactly what subset of data they're interested in looking at. So why use Fusion Tables layer? Both of the things I just showed you are possible using the Fusion Tables UI. Kathryn demonstrated before that you can extract an embed link, which you can use to embed an interactive map in your own site without having to write any JavaScript. But as developers, we often want to customize the behavior of the sites we build. We want them to stand apart from the crowd. And the Google Maps API allows you to do this. For these next couple of examples, I'm going to use a table I found publicly available in Fusion Tables about coffee production around the world for various countries over the last 5 years. Using that code I showed you before, it's very simple to add this data to a map. By default, if you click one of these features, what will happen is that the default Google Maps info window is displayed, and it's filled with whatever info window content was configured through the UI. However, through the UI, you're effectively limited to static HTML. Now, if we want to do something just a little bit more fancy, because the Maps API has additional options on the layer and allows us to customize behavior, we can achieve that. So in this example, I set suppress info windows to true, which tells the API to no longer display the default info window. And I also add a click handler. Now, the click handler function will be called whenever a user clicks on a feature in the map. And this allows me to inject my own customized code to deal with this event. So let's see what happens when we click this time. It's just a little bit different. And what's particularly cool here is that when you click on a feature, it not only gives you back the location of that feature, but it also gives you back the contents of the row in the table associated with that feature. In this case, I get back an array containing integer values about coffee production, and I can process that in JavaScript, pass it off to the Google Charts API, and create my dynamic chart, which makes it easier for people viewing the site to interpret this data. Of course, you can also combine this with other features in the Maps API. For example, styled maps, which I've used here to customize the appearance of the base map, remove a lot of the saturation, make it all very simple, and make the data that I'm showing to the user really stand out. Let's flip things around a little bit and talk about why you would use Fusion tables in the Maps API instead of some of the other built-in functionality. Now, if you've used the Google Maps API before, you'd know that you can use JavaScript to create markers. And markers can be placed on the surface of the Earth to annotate a point. However, there's one problem with markers, which is even though we've worked extremely hard to ensure that you can display between 100 and 1,000 markers very, very quickly, they still must be created in the client. This means creating JavaScript objects, and the responsibility of rendering these markers must be performed by a browser. Now, these are some measurements I've taken using a relatively modern machine and a modern browser sometime in the last week. As you go from 1,000 to 100,000 markers, the performance of the client-side marker degrades significantly, and it can take up to 40 seconds to display all those markers on a map. Now, if you use Fusion Tables layer, you can display the same number of markers in under a second. And that's really compelling, especially on mobile devices with slower CPUs and less RAM. The user of your site is going to notice the performance difference. This is achieved with tiled rendering. The data in the Fusion Tables database is rendered in the cloud by Google's servers. It renders transparent image overlays, which are sent down and put on the top of your map. The net result is that we need only 40 tiles or so to display any map, regardless of the number of features shown. So your map can scale from 100 features to 1,000 features to 100,000 features without you needing to think through the performance implications. And this is, I think, particularly compelling for developers. Now, there's one more thing I want to talk about. I want to talk about adding a little bit of style to your map. Now, this was something Kathryn touched on before. Adding styling information to your map is not only important to make your map look good, but also to convey important semantic information about the data represented on your map. Here's a map where I've gone in through the Fusion Tables UI, and I've styled the map to show areas within Australia that have fewer than 250 unique species of birds in green, and areas with more than 250 unique species in blue. But as a developer, I know that I'm not always in the best position to decide what people visiting my site are interested in. The next person to view my site may not care about the difference between 250 species, but maybe the split between 300 species or 350 species. Which is why I'm excited today to announce that you can now dynamically update the styles on a Fusion Tables layer using the JavaScript API. So if I drag this slider here to 300, our map will be restyled to represent this information. Now, this is great because you can now have users interact with your site, tell you what they're interested in knowing about your map, and restyle your map to convey that information in a way that's very easy for them to see. So how's this done? It's very basic. We've added a style property to the Fusion Tables layer. This takes an array of styling objects, which can be used to customize the appearance of your map. We'll start with a simple example. This one is a simple styling object that sets all polygons to have a green fill. If you put this on your map, you get something that looks like this. But we can combine this with other styling objects. So let's add another element to our array. This one is a restricted style. We've added a where clause, which means that this style will only apply to elements that match the condition of having more than 300 unique species of birds associated with them. And in this case, we're going to set the fill color to blue. Now, if we combine this in the array with our previous style, both styles will be applied in order, with later styles taking precedence where they conflict, in this case, on the definition of the fill color for a polygon. So now we get something like what I showed you before. But we can do something even cooler. Styles cascade in the same way that you would expect CSS styles to. So if you don't provide a full definition for a style, it will inherit elements of that style from previously matched features. So let's restrict this to features that have a population of more than 5 people per square kilometer. And in this case, we're going to set the fill opacity to 1, whereas previously it was about half. Now, this is going to cascade with our previous styles. So we're going to see a couple of distinct types of features. Some features are green with 50% opacity. These are where there are fewer than 5 people per square kilometer and also fewer than 250 species of birds. Some features are blue with 1 full opacity, and this is where there's more than 5 people per square kilometer and more than 300 unique species of birds. And already this map is conveying useful information to me. Everybody loves the east coast of Australia, right? Just by glancing at this map, we can tell that the highest concentrations of both people and unique species of birds is along the east coast of Australia. So by combining these styles, we can represent multiple different strata of information on a single map. I think that's really cool. And the final point is that this can be dynamically updated. The styles array is an MVC property, which means in the Maps API JavaScript, if you update that property at any time, the map will automatically update to represent the new state. So let's have a look at a little example. Maybe I'm a little bit over birds now. I'm more interested in plants. So we'll create a new style that colors the map red where we have more than 1,000 unique species of plants. We're also going to create a function called UpdateStyle. It's going to read back our previous definition of the style, which is this array we've passed in. It's going to override the first style in that array with this new style about coloring the map red where we have plants. And we're just going to hook that up to a button on our map. Every time someone clicks that button, this code is going to run, the property will be updated, and the map will automatically update to reflect this change. So if we click this button, recolored, right? This is great, because as I said before, you're now no longer limited to deciding exactly what you're going to show your users in advance, but instead allow them to sift through the information that you can make available publicly on your website and extract exactly what they're interested in. Couple of pitfalls. As I showed you before, you can restrict what data is shown by passing in a where clause as part of the query object. In this example, I've restricted the data to only show elements that have fewer than 100 unique species of birds. But I've also very cleverly decided to add a style that only applies when there's more than 100 unique species of birds. Obviously, that style isn't going to take effect. Just something to watch out for. Of course, in all these demos, I've shown polygon styles. You can also style other elements of the map. You can control the border thickness, color, and opacity for polygons. You can control the thickness, color, and opacity for polylines, which you could use, for example, to represent routes or driving routes. And you can also control the appearance of markers or points by selecting from the set of icons offered by Fusion tables. Couple of things worth knowing. Styles can be applied to any table, not just tables you own. So you can take someone else's data, and without owning that table in Fusion tables or needing to clone it, restyle it on your own website to represent what you're interested in. And you don't have to worry about the styles on that changing underneath you, because you can always ensure that you control the default appearance. With Fusion Tables layer, you can have up to 5 styles per layer, and you can have up to 5 different layers per map, one of which can contain styling information. And this is still part of the Maps API experimental features. We wanted to push this out so that you as developers can get started playing with it. There might be a few bumps along the road, but we're working hard to ensure that this works as stably as possible. And even more exciting, this is live today. The reference should have gone out sometime in the last 10 minutes. So you can start building websites that use this feature as soon as you leave this room. I'm now going to pass over to our guest, Simon from the Guardian data blog, who's going to talk about how he's been using Fusion tables out there in the real world to help build his site.
Hi, I feel a bit of a fraud here because all you people here actually make things, and I'm not one of the people who makes things. I just take advantage of things other people have made. But we do use fusion tables quite a lot, and we're just scraping the surface of what's possible. I'm totally kind of aware of that. I explain a bit about what we do and then kind of how we use it. So I edit something called the data blog and the data store, and what we do is every day we just publish raw data around the news. So, for instance, this is the site today. So we've just had this UN report on the population, which projects the population to the year 2100. And we'll take that data, we'll make it more accessible. We publish it using Google spreadsheets because it's just such a good way to share data. And we'll show visualizations. We use fusion tables quite a lot for that. And we use people like these guys did this stuff for us. We put that data out there, and we put it out there so that other people can then do stuff with it and give it back to us. And I suppose the reason for that is that because nowadays nobody trusts journalists anymore, and they don't really trust what we're telling them. So we can say, well, this is the data behind the story. We can make that story real, and we can bring it to life. And I suppose it came out of the fact that we were just accumulating all this data, and there's so much data, raw information out there, but so much of it is available in totally inaccessible formats, in PDFs or badly formatted documents. We've got something called the Office for National Statistics in the UK, which publishes tons of data, but they're used to publishing books. And so they publish data as if it was in a book. It's all formatted prettily with lots of lines and merged cells and stuff, which is no good if you actually want to do anything with them. So I guess the reason we came across fusion tables was because, like a lot of places, we have a real kind of dev time famine. We have a lot of developers who are really busy on creating enormous things, but actually if you want something built, you have to really justify it. And often I can't necessarily justify getting my map built compared to, I don't know, building the iPad for the Guardian or whatever. So you've got to kind of justify it in that sense. So we just kind of came across fusion tables. And at first, when somebody told me about fusion tables, I didn't really get it. I didn't understand whether it was a spreadsheet. It wasn't really a spreadsheet, and it wasn't really, so I didn't understand how to use it. And someone said, oh, it's a really good way for making maps. And that's kind of how we got into it. And this is one of the first things we did, which was the Blitz. People in the UK are obsessed with the Second World War and in general. And the Blitz in particular was this big attack on London in the year of 1940. And it turned out that basically the London Fire Brigade kept these records during the Blitz, which are all kept in the London Metropolitan Archives in a great big book, obviously, neatly typed records. Every time the fire brigade was called out to a bomb, somebody would go back and type up a record after it, which is pretty amazing considering what they were going through at the time. And we thought, well, we should just take that data. And there was too much data to record every day. There was like 800 days of this. But what there was we thought, well, let's take the first night of the Blitz and see what we can do with this. We created this list here. And all we had for that list was we had a time, we had a location, but the location was a street address. And that street address would be a street address that might not exist anymore, or it'd be a partial postcode. Every street, like you have zip codes here, every street has a postcode in the UK. And you might just get a partial address. And what is that street there, Southwark Street, that might not exist. So what we did, we did this table, we put it in, and then we thought, let's try it in fusion tables and see what it does. And because it works like Google Maps works, it basically found 95% of those addresses just by having the first name of the address. And we added London, UK, because it seemed to default to America otherwise. And it would find 95% of those addresses. And then we could correct the ones that were missing. So out of those 300 places, you could then find the other ones that are missing and easily kind of adjust them. And the fact that we could do that, and just you create something then which kind of brings that data to life, and it means you can see what happened. And people were going on there and exploring the data and say, oh, that's why there's a new building at the end of my street. That's what happened there. And that's kind of just a really nice way for us to be able to display that data and make it real for people. And do something online which kind of takes advantage of the features that you've got there. This is something else where we've got a lot of data. Now, the other thing that we're obsessed with in the UK is school results. And especially I'm a parent, so obsessed with where my daughter's going to go in 5 years' time. And the government every year releases secondary school results, and they release it with the school name and a postcode and an ID code for that school. So because you've got an ID code for that school, suddenly we can start kind of mashing that data together and bringing it in with other data. And they also release data on how much is spent for each pupil in each school with the same ID codes on but separate sheets. So we could bring that stuff together, and we could do stuff like this, which is what goes in the paper, which shows kind of the spread by local authority across the UK of how much is spent on each pupil and so on. But the really cool thing of being able to bung all of those schools into a Fusion table really brings it to life for people online, again, in a way that, could do that. In a way that we wouldn't be able to do otherwise. So being able to have each of these as a school that you can then click on and you can find your school. And we started zooming into where I live, which is down here. Let's see if I can zoom into that. So each of these dots is a secondary school. And secondary school in the UK is where you go to from 10 to 18. And you do A-levels there and so on. And the fact that you can get really close here, let me just find, I need to find a school. And for each school you've got, and you can style that stuff up and you can say how much, so that school there is £8,000 per pupil, and you've got the results there, and you can start to compare real life data and actually tell you something. It's a kind of useful way for us to be able to kind of make that data come alive for people. But then being able to just use it in a kind of a standard way every day is really useful too. So when they had the Fukushima accident in Japan, being able to take that data and then use it so you can highlight different events. Let's just go to the full screen one. Often our layout is too small, but the fact of being able to style this stuff up and being able to kind of pick on different places is just a really useful thing for us. And we can update this and add to it and it'll display on there. Because traditionally, and this might sound weird to you guys, every time we've done a map online, it's meant somebody in Flash manually kind of drawing each place or drawing each border. So it's quite new for us to be able to have stuff reading on spreadsheets. And then to be able to do it without involving developer time is just a really good thing. So that's this one. And then here's another kind of example of big data. This is the government in the UK is obsessed with open data at the moment because it's a very easy way to appear transparent. And so what they've started doing is publishing things like this is every public building in England and Wales and what its carbon emissions are. But the problem was that they wouldn't release the full data, so somebody put in a freedom of information request and got this, and then they sent us the data, and we used Fusion tables to map that. And what you've got there is you've got thousands of public buildings. And the fact that we can show those all, we can color code them all up by different types of missions, and you can see kind of how much. You've got a lot of buildings there. The reds are the worst ones, of course. So let's see if we can go into some of these. And you can see where all the public buildings are as well. So you've got the type of building it is and so on. And being able to just kind of show that information quite quickly, and creating something like that took about 20 minutes. And that's, again, that's really, really useful for us. And then we got the WikiLeaks data. Now, obviously, WikiLeaks is a lot of data. We had, there were 3 releases. There was Afghanistan, Iraq, and the big cables release at the end. And with the Afghanistan data, that was about 90,000 instances. The Iraq data was 391,000 instances, which makes the Iraq war the most documented war in history. If you think the Pentagon Papers, which came out about Vietnam, were 7,000 documents. So having 400,000 documents, we know everything there is to know about that war. And it became obvious quite quickly that the big story was just the huge numbers of people that had died. Even on this database, 109,000 people died. That covered everything from coalition troops through to Iraqi civilians and so on. And we did 2 things for this. We did this thing here, which is quite beautiful. Took a lot of technical time up. It's basically just presenting one day in the life of the war. We had a Guardian correspondent writing this kind of lovely piece to go with it, and you could kind of click on different events, and you could watch through it and so on. And then, so we did that. And then I had this data set, which I've been using to do some analysis on, which was basically every incident where somebody had died. And there were 66,000 instances where at least one person had died. We thought, well, maybe we should just put that on Fusion tables, see what it shows us. And it might give us something we could show on the site. It wasn't something, to be honest, we spent that much time on. And this is what we got back. And this is the most popular interactive map we've ever done. And basically, each of these dots here is an incident where at least one person died. And because there are so many, it gives you a real sense of the war. And it tells you more than you could write 15,000 words on how many people have died in Iraq, but to actually see them like that totally brings it to life. Now, anybody got any thoughts on which was the most popular out of those 2 interactives? was this one. And I think the reason it was this one, the one that we hadn't spent all that technical time on, was because it allows people to explore the data for themselves. And a lot of this interest in data at the moment is about people feeling empowered by data, feeling able to find out about things they didn't understand about before and to discover things. And that's exactly what this allows us to do. It gives you a way to explore the data for yourself. And you can zoom in and out. But the great thing about zooming out is it gives you a sense of the war in terms of patterns. You see you're already starting to get these groupings as you pull out. And see these roads along here where lots of IED attacks, and you get a real sense of what's happening across the country. Now, if you're driving down that road every day, you might feel a little bit nervous, for instance. So you get a real, and that tells you the story of the war, in a way that, like I say, thousands of words wouldn't necessarily do. And then one thing we've been experimenting a lot with recently is this, is being able to map countries. Now, again, for us to draw a kind of a map, traditionally it's been our Flash guy kind of just drawing it, or we have done some stuff where developers have done stuff, but for me to be able to create a map like this is a new thing. And what this is our Foreign Commonwealth Office, which is the equivalent of the State Department here, they issue travel warnings about countries that are safe to go to. And we thought, well, this was just after Egypt had changed, Libya had kicked off and so on. We thought, let's just take a snapshot of the Foreign Commonwealth Office's travel warnings. So we scraped the site and we kind of graded the travel warnings from don't go here at all to you can go here, it's fine. And this is what we got, so it's going to say. And the great thing is, actually, in terms of our style, that isn't a million miles away from how we would style that map anyway. We would use those kind of borders. We would use 100% opacity anyway. And the great thing is you click on that and you can embed the HTML, and that tells you about, don't go to Libya. Maybe don't hold in Afghanistan either, but you can kind of go to Iraq. Oh, Pakistan, yeah, Pakistan partial. Don't know. And so on. It just gives you, it's just a useful, it's all travel there. Don't go to Iraq, okay. Just ignore what I said on that. So for us to be able to create something like that and to put a story up quite quickly is, it's just a really, really good thing, and it's really kind of what we're about. And then there's this one here, which Kathryn mentioned earlier. Now, what happens is the government, every 4 years, they do these things called deprivation indices, and they're really important in the UK because they're how the government plans out all its funding. So it's basically a measure of how poor people are in different parts of the country. But of course, they don't use a boundary that's recognized in any other way possible. We have, in the UK, we have counties, which are quite big. They're a lot bigger than the counties you have here. We also have wards, which are maybe similar to the counties you have here in the States. Our counties are more like states, just to confuse things. But they also have these little areas which they only use for this data called lower super output areas, which are basically small things, and maybe 10,000 people at a go. So for us to manually map that would be impossible. But it's not like we can embed the official version. This is the official website. And if you want to kind of find out about any of these places, it's slow, it's kind of clunky. You don't know what these places are. Look, see, it's just trying to load here. It's pretty poor. And it doesn't give you a picture of kind of the whole country as a whole. You can't see the whole country at all. It doesn't rank it. It just allows you to kind of to zoom down eventually. See how slow it is there? Oh, OK, we're getting somewhere. Anyway, it's pretty poor. So we thought, well, we've got all that data. It'd be great if we could do something with it. So firstly, we had to find the polygon data, which is a bit of a pain in the neck. Eventually we found an academic. So each of the little areas is super output. But imagine having data at that granular level. It's really useful. But we had to get the polygon data, which was as difficult. But once we had that data, it meant that we could create something like this. Yeah, let's click on it and go to full screen. So basically, that is everywhere in England and Wales, and the deeper the reds get, the poorer it is, and the deeper the blues get, the richer it is. So that's London. It's kind of kicking off in London, and we can find for you the poorest place in Britain, just because I know where it is. You see, these areas out here are quite wealthy, and you've got the score there. It's coloured up by the score. We've got a bit of explanatory data there. And see, over here, it's quite wealthy at all. And then, so the great thing is to be able to show that kind of data and be able to illustrate it is really, really a new thing for us. Be able to, and it gives you a picture of the country you can't get in any other way, and it's better than the official site. So what's not to like about that? I'm going to show you one last thing that we did last week. We're kind of running out of time, aren't we? OK. So last week, we had 3 major elections all on one day in the UK on Thursday. There were 2 devolved parliaments in Wales and Scotland elected their members, but we also had a vote on our voting system. At the moment in the UK, we vote first past the post, which is where basically the person who wins the most votes in a seat wins. That's how it works. And then, they wanted to change to a more proportional system called AV. Anyway, it didn't win. It was a bit of a disaster for the campaigners. But basically, we wanted to kind of create a live results map. We didn't really have very much time. We thought, how are we going to do this? So we basically we created a merged table. We merged together one map which showed, and the problem with this, the tricky thing about it is that in England we had to have local authorities, and in Scotland we had to have parliament seats, and in Wales we had to have parliament seats. So we managed to put those all together using the Fusion Tables merge thing. And then we had the data in a separate sheet, merged that together too. And basically all we had to do to change this map, to make it live, was every 10 minutes just to update the data on the data sheet. And that's all we had to do, just load in the new spreadsheet, because we were getting a spreadsheet download of the results, just had to upload that. And so it turned that map into a live map, and people were using it during the night. Every 10 minutes it was like a 30-second job. So so for us to be able to do that is just a great thing to be able to turn it around quite quickly. And we use the same colors as the styles for the newspaper, and it just makes it consistent, and you can do this kind of nice stuff. Everybody voted no, apart from Glasgow. There you go. These purples, the purples are the only places that voted yes. Edinburgh and Glasgow, and a couple of places in London. There you go. So I suppose to sum up, to say that what we're about as journalists is telling stories and making data come to life. And what Fusion Tables has done is give us a tool to do that. Thanks a lot.
All right, so just wanted to go through a quick summary of what we showed you today. So I talked about new features for trusted testers in the Fusion Tables API. These include map feature styling and info window customization. And James McGill talked about the new feature in the Google Maps API, and that was dynamic styling. And I just wanted to provide a few links for everyone. Link to Fusion Tables API, etc. I'll leave this screen up here while we take some questions. So if James McGill, you want to come up? And so we have a few minutes for questions. And you can also ask questions to Simon Rogers as well.
Yes. Just want to confirm the maps generated through the styling, are they tiled? Are they tiled, cached tiles?
Yeah, through the dynamic styling.
So if you do the dynamic styling, it also generate the tiles.
Yes, correct. So you still get that performance gain even with the dynamic styles.
In terms of the tiles size, dimension, we still only have 128 by 128, or?
It's 256 by 256, but it's just an implementation. It's not something that you need to worry about.
Okay, what about if we want to push to the mobile? Would you allow us to do 64 by 64, or?
We found that the current tiles work really well on mobile. They come down relatively fast, and you get that because you're not dealing with having the number of client-side objects, the performance is going to be better on mobile.
Second, really quick question. The Fusion table, the geometry type you mentioned is KML. Any other geometry types you support?
So you can enter in street addresses if you have your location data, street addresses or lat longs or points. What else? What was that? Oh, other tools. And if you have shapefiles, you can import shapefiles to Fusion Tables using a tool called ShapeEscape. So it's shpescape.com.
All right, thanks.
I think over there.
Yeah, I just have a question. You showed in the API on how to insert data one at a time into the Fusion Tables. Is there a bulk API for loading gigabytes worth of data or whatever?
You can send up to 500 inserts at the same time.
Okay.
Just separate them with a semicolon.
Do you have to then check and resend the 500? I mean, I can obviously see, let's say, network timeout or success failure, that being kind of a, you know, if you had to insert, let's say, 10,000 data points or into a fusion table, so you 500 at a time, something times out, check for response, have to resend those. I mean, is there like just a bulk upload type of facility available?
So if the request is successful, return the row IDs. If not, then the inserts didn't fail and you have to resend all those inserts.
Right, so, but 500 is the maximum at a time that you can upload.
Yeah, at this point. But it would make a good feature request to be able to allow more. Yes.
Question to James. In Fusion Tables layer, if you have point data, lots of it, and you're using tiling, how do you manage to generate tiles that don't split the points and are able to show them as whole?
Across tile boundaries?
Yeah.
So we use a method that ensures that the same points as, if a point is selected in one tile, it's also selected in all other tiles. So that guarantees that if that point crosses the border of multiple tiles, because it will be present in both tiles or all 4 tiles, it'll render correctly. Okay. So people viewing your site shouldn't, with the exception of the fact that Fusion Tables layer doesn't let you drag your markers, for example, they shouldn't be able to tell the difference between Fusion Tables layer and you having created these points manually.
I have KML that is using the timeline feature, modeling 311 data, you know, potholes, graffiti, abandoned cars, that type of stuff. I have about 10 years of that modeled for showing in Google Earth. Can I upload that to Fusion Tables and still have the timeline feature?
Oh, we do have a storyline, but is this something that you want to show on a map?
Yeah, I want them, just like they do in Google Earth, I want them to be able to draw those 10 years and close and open the, you know, when the things were going on, abandoned cars, graffiti, where they were at, and all the rest of that. Is Fusion Table supporting the timeline?
No, you can't do anything like that in Fusion Tables.
But you could use, for example, some JavaScript, the Maps API, to achieve, I think, the same effect.
Yeah.
Hi, the political boundaries you showed, is it something Google offers for all the countries, or something you expect the user to create those political boundaries, different states for each country?
Google provides Fusion Tables, but the data is generally uploaded by users. The advantage is that you can mark data as public, so you could upload some political boundaries and allow other people to fuse that data with their own data. And we've seen a lot of people have uploaded their own state borders, country borders, political borders, and other people are making good use of this, combining it with other information they have to make these maps.
I see. And one more question is, if you have a Fusion table, say I have around 1 million rows of data, is there a way the person who is using it, they can only see a subset of the data? Like I'm logging in from Northeast, I can only see Northeast data. Somebody is logging in from Southeast, they can only see Southeast data, but the data that is there in the table has all the data I need.
So you could use the, in the example I gave where I restricted it to only show points where age was greater than 50, you can of course use spatial queries as well. So you could get the current location of the user and filter to only show points that were within a certain radius. Or if you had a bounding box for the area in which you wanted, you could filter to only show those points. So yeah, I think that's possible.
Okay, thank you. Good presentation.
Thank you.
Does Fusion Tables, can I optimize any KML that I put into it? Let me rephrase. If I have highly detailed KML, normally huge files, if I put them into Fusion Tables, will that be optimized when I try to build a map? Or do I need to strip that KML and simplify it?
So we're talking about simplifying polygons?
Correct.
Yes. So the idea is that when that data is uploaded to Fusion Tables, we do offline simplification to make sure that it shows efficiently on a map. So you don't need to worry about that as long as you can keep the KML within a size that can be uploaded to Fusion Tables.
Yeah, I'm not sure I can, but that's outstanding either way.
Or consider splitting it into multiple files,
right.
Adding multiple layers,
right.
And that's another way to aggregate data.
But still, that sounds like a great feature, so thanks.
So for rendering point data using the Fusion table layer, do you have any plans to allow for custom images, like custom marker images? Because currently you can show dots of different colors and different sizes, but if we could upload,
sure.
say...
I think that would be compelling, so file a feature request And if that's something enough people are interested in, then maybe it's something we will look at.
Okay.
We're actually out of time, but I think both Kathryn and I will be hanging around I/O. We'll be at the party tonight, so if you have any more questions, or come up to us after, and feel free to ask us questions. Thank you.